this is true, of course. So one of the most frequently asked questions is, are lab-grown diamonds real diamonds? And the answer is yes. They have the same chemical, physical, and optical properties as natural diamonds, but they're man-made in a machine instead of the earth. Both natural and lab-grown diamonds consist of carbon atoms arranged in a cubic crystal structure, and this defines their chemical identity, regardless of their origin, and distinguishes them from their simulants, such as moissanite and CZ, which are composed of entirely different elements. Simulants should never be referred to as lab-grown diamonds or synthetic diamonds. So when the carbon atoms are arranged in any other structure, not a cubic crystal structure, then they're a different material, such as graphite or amorphous carbon, which is here when they're arranged in this random structure. So we actually see amorphous carbon on the edges of CVD crystals as they're growing. So the center is a single crystal diamond, and this is in the shape of the wafer or the seed. And then as it grows, this non-diamond carbon ends up around the edges like this. So the cubic arrangement of carbon atoms contributes to diamond's remarkable properties, including its chemical properties, such as resistance to corrosion. In life, we see these properties that diamonds are exceptional in cutting tools even under really extreme conditions. And diamonds are also being researched for several different medical applications in the future. Natural diamonds and lab-grown diamonds also have the same physical properties, such as hardness, toughness, density, and thermal conductivity. So in life, this makes them very valuable as heat sinks in high-powered electronics, and in the future, maybe quantum computing. But more importantly for us in this industry, as the hardest material, they're ideal for engagement rings that are worn on the hand every day. And on the Mohs scale of mineral hardness, you can see diamond is by far much harder than corundum, which is a 9 on the scale, diamond's 10. So it's actually, diamond's 4 times harder than corundum. So what does this mean? How do we see this? So this is an example of my friend's ring. She wore it every day for many years, and you can see that the sapphire has so many scratches and chips around the crown. Even though this is a 9 on the hardness, it's still, over years of wear, it'll definitely show the wear and tear. And this is an example. This was an interesting ring that was sent in for identification. This is a 10-stone band. 2 of the stones here are diamond, and the other 8 stones in the band are moissanite. So this one here, and this is the same diamond. We just turned the ring a little so you could see the surface. So moissanite's 9.25 on the Mohs scale. But you can see, like this, every single moissanite in this ring is really destroyed compared to the condition of the diamonds. So that's the physical property of hardness. And lastly, the optical properties of natural and lab-grown diamonds are the same. This is a subset of the physical properties, but it deals specifically with how light interacts with the material. So this is like refractive index and dispersion. So in life, how does this look? These are fire videos showing examples of the different levels of dispersion that we see in simulants and in diamond.